Hi aviators, welcome back. Well, today is, pretty much your first week of school. I hope it's going well. I know that it could be a little confusing and some things we haven't done before, like the Google Classroom, but I know that you guys have got a lot of experience and you're so bright. I know you guys will figure this out, and just know that we're here for you. We love you and we look forward to seeing you guys again. Okay, so for the first couple weeks, I'm going to be doing all the recording for 8th grade, and Mrs. Fellows is going to be doing all the recording for 7th grade, just until we get our feet wet and we kind of know what we're doing, and then we'll go back to the way we were doing it. Anyways, I know that we started this PowerPoint and my class did not finish it. So I'm going to go back and review it a little bit. I have tweaked the PowerPoint a little bit, so it's different from when we did, a little different from what we did inside of class, but it's a good review. So I'm kind of making it a little bit more comprehensive so you guys kind of remember what we're doing, because it's been a couple weeks now. And we go on. So the first slide that I have for you is our standard. Is going to be apply specific ideas to construct explanations for the anatomical similarities and differences among modern organisms and between modern and fossil organisms to infer evolutionary relationships. Okay, so our essential question is, what kind of evidence do you think can be used to explain and support evolution in organisms, including humans? Okay, so the whole idea that we're looking here is, how are we going to support this big idea of evolution? Like, is it true? Is it not true? What kind of evidence do we have to be able to say, hey, evolution happens, it's still happening? How do we know that? Okay, so let's go on. All right, so let me go back here. Our first lesson that we did, we played that game where we were passing on the germs and stuff like that, and we're kind of seeing like who we were in effect, who were not in effect, and we found out that if we got vaccinated, that we had a better chance of survival. And that over time we realized when we answered our questions that the flu actually evolves, and that has to do with the flu evolution reading that you guys did on page 129. I'm going to be referring back to the book, so if you see me look over to the side, I'm just looking through the book, okay? And then our second activity, we went through and we saw a tree, and that one is, oh no, I'm sorry, I lied. Hold on, we'll go back. Lesson 2 was just some questions that we answered. And so I'm going to take you to activity 3 was the flu evolution. And I have an article right here that I thought was kind of interesting. You don't have to do it right now, but it was something, especially like with the coronavirus and all that right now. I thought it'd be kind of cool if you guys went in and kind of learned a little bit more about the evolution of a virus. Some of you, I think you might be getting bored at home. So if you do, I'm putting a little bit of extra stuff in here just in case you get bored at home. Okay, so the flu evolution was the reading that you guys did, and let's go on. Activity 4 was when we saw the tree, okay, and let me move myself out a little bit. Okay, so we see this tree right here, all right, and right now we came to speculate that as a human being right here, that yes, we did not branch off of apes, but we found out that we're like cousins to an ape. Okay, so on here we realize, like, you know what, we share a common ancestor. So somewhere down the line we have a common ancestor, but we did not evolve from the ape. We just have a common ancestor, and that's what the tree is showing you. Darwin at one time insisted that we evolved from an ape, and as time went on, as his life went on, he realized that that was different, and that no, we did not come from apes, but we do share a common ancestor. And that's what the tree is depicting on here. As you can see right here in the branch, okay, we didn't evolve like right here. If we evolved from the ape, then the ape would be down here. But on here, it shows us that we're cousins to an ape because we have a common ancestor. We are right here. Okay, so I hope that helps, a good depiction on that. Okay, on activity 5, you guys read an article that was on both fact and theory, okay? And so I just went ahead and I just wrote out for you what a theory was and how it all kind of combines with saying, okay, so it's a theory, yes, but it's also a fact because we have lots of observations and lots of measurements, okay? And that, so for for evolution is happened and it continues happening. And we saw that with the flu because the flu is going to evolve. Even this coronavirus is going to evolve over time. Okay, we have one part of the virus right now and how it's structured and all that. And remember how we talked about mutations and things like that? So who knows, next year when the coronavirus comes back around, it may be completely different. Instead of people having heart issues, people may be throwing up or whatever. That's just part of evolution. It could be the same virus, but it's mutated and evolved, and now it's coming up with a different type of symptom. Okay, so that's kind of how that's going to explain. Let's see. All right, so there are two types of evidences for evolution, okay? One is the fossil record, and this is going to be found on Activity 7. You're going to do another reading for, it's called Evidence for Evolution from the Fossil Record. And we've spent a lot of time on this fossil record. I put a few words on here with rock strata and law of superposition because we've already kind of went over those already. But just so you know, that first part of evidence, when you guys wrote that last CR, okay, we found out that the fossil record did provide some evidence for evolution. The next activity is the origin of the whales video, and we have a reading on there. We saw this video. You may or may not have seen it. If not, it's still available for you to go see. But it's called the origin of the whales, and we looked at the video and we talked about how we had this kind of like a wolf-looking creature, and then he was sitting by the shore a lot, and then he goes into the water, and that's what they're saying was the whale has evolved from that. True, not sure, but it is a good speculation, and the reason why they were able to speculate on that is because the bone structure of the whale and the bone structure of that wolf creature were very similar, okay? And when they're very similar, we call this homologous. I can't pronounce it. You guys know I'm terrible at that. Homologous. I can't say it right now. Oh gosh, it's not going to happen. Anyways, it has certain structure, okay? And when we're talking about certain structure, when they're looking at that whale, okay, let's see my hand right here, okay? In my hand, I have my phalanges, I have my metacarpals, and I have my carpals. Okay, and so they're saying, oh my gosh, when we look at, like, say, the bat wing, the human ham, the seal flipper, even the whale flipper, it's going to show that it's got a common build on that. So they say, okay, we must have a common ancestor because we have a common form. Okay, again, on this case, the bat wing, the human hand, and the seal flipper are going to be the phalanges, the metacarpals, and the carpals. Okay, and that's why they're showing it. All right, so activity 10 is homologous, I'm not gonna say it, structures and function. Meaning, in simpler words, is similar body structures and uses. Okay, so then right now we've got the dolphin, we got the bird, and the dog, okay? And you're looking at their bones right there, okay? So if you look at, let me move me again away from that picture. Okay, so we got the dolphin, we got the bird, and we got the dog. Again, similar bone structures. You see how they correlated the colors on here? You got orange, 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 and blue, 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 green, 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 and then light blue, light blue, light blue. Okay, so that's just showing you the similarities. And then the lab that you're going to be doing is going to be talking to you about that also. Okay, so I'm not going to give you all the notes on here. You're going to go back and you're going to look at this, and you can look at it with me on the recording, or you can look at it just doing your notes yourself. Okay. But I'm just kind of just briefly going over that, so hopefully to answer some questions, okay? All right, so there's a homology, I said it, video that you're gonna watch. I already assigned it for you. Okay, now there's different types of homology. There's the structures of morphology. We evolution used the part of building blocks, meaning that what I just showed you was the phalanges, the metacarpals, and the carpals. Okay, and then we also do DNA sequencing, and the DNA code is the same across all origins. So all origins of human beings have the same type of sequence, not human beings, sorry. All creatures of organisms have the same structure, okay? So if you look on here, it's gonna give you a man, it's gonna give you rat, it's gonna give you chicken, it's gonna give you frog, and look at the sequencing on there. You've got R, F, R, Y, V, okay? And you're gonna see that it goes across there like that. So you see that it it has the same type of DNA sequencing. All right, and then you're going to work on your lab. And I think you could do your lab before that. Actually, I think I put it in the wrong spot, but that's okay. I'll fix it. And then we also see evidence in evolution when we see an embryo development. Okay, and an embryo is when a creature or organism, not creature, but organism is inside the stomach of the mom. Okay, and that's what early in utero development. That means it's inside the belly. Okay, so when they're saying that there's very similar structures. Let me show you a little bit on that. All right, again, let me move me. All right, so on here, when you look at the human, okay, look at the human. This is in embryo, okay, and then this is the development, and then here is it as it goes. So as it's starting is very similar. You see the head, you see the gill slits, you see the tail, okay, and the human, the rabbit, the chicken, the turtle, the salamander. There's other ones too. There's lots of other ones, but on those ones, I'm just showing you right now. And then you can still see that it's still very similar. You see like arms budding, that type of thing, okay? And then when it starts to get closer to the end, then you kind of see it's like, okay, then it's starting to take a little bit more shape of what it's going to look like as it's going to be born. And right here you can see the human being, okay? And then you see the rabbit and the chicken, and started to take little different pieces, because our cells have different jobs. And so on here, we might have created teeth, and the chickens now, their job is to create that beak. Okay. So again, it again shows a common ancestor. Okay. All right. So there's another video for you to watch. I liked it. I think you're going to like it too. Okay, and then the last activity you're going to do is DNA and evolutionary relationships. Okay, and it's just talking about how when we're born, when we're in utero, we start as this ball. We call this a blastula. All right, and it's just a ball. Remember, we start with one cell. You've got the mom and you've got the dad. You got the egg and you got the sperm, and they come together and they make the first one cell. And then they split off. Now we've got 2, and then shortly we've got 4, then we have 8, then we have 16, then we have 32, and so it keeps doubling. And so you can see what it's just telling you is that the relationship between that is that we're all starting here as that ball of cells, okay, called the blastula. All right, and then your CER, I know I can hear the excitement right now that you are so excited that you get a right one. The thing is here, remember, when you're doing these activities, you're doing these activities inside of your book. You're not going to be doing them like on paper and stuff like that. You're going to type in there, and please, 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 you make sure that you hit submit on all your activities, okay? Because you can type it in and it'll save it for you, but I'm not going to be able to see it, or Mrs. Fellows is not going to be able to see it until you actually hit that submit. Okay, so right here you're saying activity 18 is when you're doing your CER, and it's going to ask you, it's going to give you, you're going to read all these inside your book, because you're going to read and annotate, right? And then you're going to pick one of them, which you're going to do. All right, now you have a little bit of information inside your book, but I went ahead and went online and I found some really cool websites that you could get a little bit more juicy information. And so I thought you guys would like a little bit more information. Some of you guys I know like to see all that, but it's like pet resistance, evolution of new viruses. It's the same one as you. If you looked at the one from before, then it's going to be that same one. Okay. Then antibiotic resistance, like why sometimes antibiotics stop working, faster toads, and then pollution. Okay. So you guys will have all these. I put some little pictures on the side right here that I thought would be interesting to you. I really think that faster toads one is kind of really cool. Anyways, I hope you do too. And if you have any questions, you make sure that you ask us and all that. So we look forward to hearing back from you guys. I wish you the best luck in all that you're doing. Please, we are here available. All your teachers are available. All your teachers miss you guys. And we do want to make sure that you guys are successful and get all your stuff done. Okay, so remember, ask some questions. I do have my, my Google Hangouts that I'm going to have. So make sure you jump online so that we can chit chat, and you have any questions, check us out for our office hours. Okay, we're here for you guys. Okay, so don't feel like you're all alone or you have to be frustrated. All right, guys, good luck, and we'll see you soon. Bye.